Factoring polynomials. By the end of this video, we should be able to factor many different kinds of polynomials. Well, let's remember a few things. We have already done a lot of factoring of polynomials. We factored quadratic equations. We used the Xbox method to factor these quadratics. However, this exact method of using the Xbox can only be used for quadratic equations. Some teachers call them the diamond problems, but you've done those before. You definitely did those in Algebra 1. And we have talked about in Algebra 2 as well when we were finding the roots of quadratic equations. Sometimes we call those zeros or roots or the x-intercepts. The way we did that was by factoring the quadratic equations. So let's talk about a few things here. So we're going to talk about factoring polynomials, not just quadratic equations, but polynomials. But most of the factoring is done with quadratic polynomials. But let's talk about a few things. So factoring all polynomials. Well, let's take a look at this. This is a trickier process because not all of them can be factored. And there are different strategies in factoring them. Step 1, anytime you are supposed to factor any type of polynomial, you should always see if there is a common factor that you can factor out. So that would be step 1. See if there's a factor in common with all of the terms to factor them out. In the next video, when we do example problems, we're going to have stuff like this. The very first thing we're going to look at is to see if they have something in common. If they have something in common, we're going to factor that out. And then we'll take a look at factoring what is left. Step 2. See if it is a factorable quadratic polynomial, because quadratic equations or quadratic polynomials are the easiest kind of factor because we use the Xbox or the diamond problems, whichever your teacher has always called them. So we just use the diamond or the Xbox and we see if we can factor them. Step 3, see if it is a special case polynomial. There are many kinds of polynomials that are special cases. Here are some special cases right here. All you have to do is get a 2x2 box, put the values inside the box, and then factor out of the box, just like we did with the Xbox. The sum of two cubes is a special case. A cubed plus b cubed, here's the formula right here. A plus b in parentheses times the quantity a squared minus ab plus b squared. Also, the difference of two cubes is a cubed minus b cubed. Well, that is equal to a minus b times a squared plus ab plus b squared. These are just formulas that you're going to have to remember because these are special cases. The sum of two cubes and the difference of two cubes are special cases. For quadratics, we have the difference of two squares, but you could still just do that with the Xbox. The difference of two cubes cannot be done with the Xbox. The sum of two cubes and the difference of two cubes are special cases that you cannot use the Xbox on. So you're just going to have to remember these two little formulas right here. Okay, let's talk about the factor theorem and what this does for us. For any polynomial px, so just px is any polynomial, x minus a is a factor of px if and only if p of a is equal to 0. This sounds a little tricky. Let's try to make some sense of it right here. Let's do this example. Is x minus 1 a factor of x cubed minus 3x squared minus 13x plus 15? Well, looking at the factor theorem, if x minus 1 is a factor of this polynomial, that would mean that p of 1 is going to be equal to 0. So what I could do is I could just substitute 1 in for the x's and see if I get 0. However, in the last lesson, we learned synthetic substitution. I can just use synthetic division and see if my remainder is 0. It does the exact same thing, so let's do that. So I'm going to put 1 on the outside, because remember, we do the opposite. It's x minus 1, so I just put 1. And the factor theorem tells us why I do the opposite. And then I do the coefficients. 1, negative 3, negative 13, and a positive 15. And I'll just go ahead and use synthetic division. So I drop the 1. 1 times 1 is 1. So I write 1 up above. So negative 3 plus 1 is negative 2. So then I go 1 times negative 2, and I get negative 2. And now I just add those together. Negative 13 plus negative 2 is negative 15. And then I just multiply the 1. Negative 15 times 1 is negative 15. I add 15 and negative 15, and I get 0. So we know that x minus 1 is a factor because the remainder was 0. Because from synthetic substitution, we know that if the remainder is 0, then p of 1 equals 0. because the remainder is what p of 1 is equal to. And then by the factor theorem, since p of 1 is equal to 0, we know that x minus 1 is a factor of x cubed minus 3x squared minus 13x plus 15. So now let's just go ahead and interpret our information. We know that x minus 1 is a factor, and then we also have 1x squared minus 2x minus 15. Because these are the coefficients of our next polynomial. Since we divided into a cubic polynomial, I know that I'm going to have a quadratic polynomial because it's going to be one less. So I'll just go ahead and write it. X minus 1 is one of my factors, times x squared minus 2x minus 15. Now I wonder, can x squared minus 2x minus 15 be factored? Well, by using the x box, or the diamond problem, however you're comfortable calling it, so by using the x box, I can see that I can factor this into x minus 5 and x plus 3. So there are the three factors of x cubed minus 3x squared minus 13x plus 15. It completely factors into x minus 1 times x minus 5 times x plus 3. All right, in the next video, we'll do some more examples of these, and I know you're going to get more comfortable with it.